So we've arrived at our main event, which is histograms. Histograms are graphs, graphical displaying data tools for quantitative data in particular. Histograms are really helpful once you already have a frequency distribution in any form. So it can be your regular flavor, it can be a relative frequency distribution, or even a cumulative frequency distribution. So I'm going to briefly show you using that example we were working with in the previous video to illustrate what this looks like when you have the frequency distribution already set up. And sometimes you won't have it set up already. You'll have the raw data and you'll be asked to create the histogram. So just know that when you create the histogram, implicitly you're creating the frequency distribution first. So there is a precedence there. The frequency distribution is what allows you to create the histogram. One really important thing to note here is that a histogram is similar to a bar graph. We're going to have vertical bars of equal width representing frequencies. But what's important about histograms is since we don't want quantitative data to fall through the cracks, each class, remember, represents a category of numbers or data values that fall into that class. And so the purpose is slightly different. Instead of representing a category like a name or a label, we're representing a range of data values. So when you're setting up your histogram, you're going to probably set up an L here where you have a horizontal axis and a vertical axis. The vertical is the frequency. So make sure that you evenly space out your tick marks representing the frequencies, and go with nice numbers that are easy to work with. Try to avoid, picking out these exact frequencies. So for instance, the highest frequency is 29. So maybe I'll choose this to be 30. And so halfway in between that would be 15. And then you can fill in the gaps from there, right? So maybe 5 and 10, and then 20 and 25, something like that. You want it to be relatively, even if you're not getting it perfectly, you want the spacing to be fairly even. And it's easier to do with a tech tool like Excel or Google Sheets. But if you're doing it by hand, this is the way to go. Now with the classes, when you're setting up your horizontal axis, what you want is to start from, if you want to use the lower class limits, you want to start all the way at the very bottom. So right at the corner. So this corner represents 0 vertically and 5.0 horizontally. And then just decide on a width for your bar. It can be 4 boxes, 3, whatever you think is best. And so I'll go every 4 boxes. And so I should have bars of equal width when I'm done. And then you can set up the bar itself. And the important thing is make sure they're touching. So here's my first bar. And its height is 1. It's hard to see because of the scale, but sometimes you can get more precise if you want. Sometimes it's just not important. And for the 6 to 6.9 category, we're going to represent this with a bar that looks like this. So I'm trying to keep the width of the bars fairly even. For 7, that goes up to 29. That's like right there. And then lastly, for the 8 category, that goes up to 7. So I'm just going to start here and come down here. So there's implicitly there's like a 9.0 here. But so then these are my four classes and their frequencies represented as vertical bars in a histogram. So importantly, there should be as many bars as there are classes, and you can annotate them if you want, highlighting the frequencies. So it's really helpful to visualize what the data represents. So remember, these come from a raw sample data set. And it's a sample of baby birth weights measured in pounds with precision of 0.1 pounds. And we said our N was 48. So 48 baby birth weights recorded in this data set. And this is the corresponding histogram. A note, when we say histogram, we mean we want that to come from a regular frequency distribution. So this table here. On the other hand, if we say relative frequency histogram, so now this is distinguishing what kind of histogram we want. That comes from a relative frequency distribution. And something really cool relates the relative frequency histogram and the original flavor of histogram, in that you actually don't have to modify a whole lot to get a relative frequency histogram and backwards. Here's why. So if you recall, we said each relative frequency is the regular frequencies, the counts, divided by the sample size, okay? Now the sample size is true for each class. It doesn't change. So when we compute relative frequency, so I'm now going to start setting up our relative frequency. We're just rescaling each of the frequencies by dividing by n, which in our case is 48, so, go ahead and put that in. And we did this in the previous video where we found what each of these relative frequencies is. But what's really awesome about this is that when you rescale and you want to represent your relative frequency histogram, you don't have to change the bars themselves. All you would be changing, and I'm going to use, I don't know. Okay, we'll use the same color. But if you remember, the relative frequency, so we found each of them, the highest one was just under, or just above 0.6, so just over 60%. So maybe we'll go up to, we'll say this is 60%, so 0.60, which means that half of that is 0.30, and then half of that is 0.15, and then in between here is 0.45, right? So just make sure it's evenly spaced. And if you go and check the relative frequencies, then, so we have 0.02, 0.22, 0.6, 0.14. And those are pretty damn close. I mean, obviously, if we were doing this correctly, but by which I mean, if we were being really painstaking about getting the scale properly, then of course this should match perfectly. Okay? So my imprecision here, don't copy that. You want to be a little bit more mindful about the way you set up your vertical scaling. But this is the idea. So now we have a relative frequency histogram, and we didn't have to change the bars at all. So the actual when we say distribution, right? So distribution is the concept of how are the data arranged? And so when we see this pattern here, actually something very special is happening here that we'll get into later. Oops, that doesn't look very right. That doesn't look like a good fit. This is an example of what we would call a bell curve shape. We'll get into that in the next chapter, and it's actually very important, and we'll see many examples of it throughout this course. So we're going to start to shift eventually from, okay, how do we represent the data and how do we interpret, analyze the data? So just a sneak peek there. But not only can we do relative frequency histograms, but we can create cumulative frequency histograms, which you might have guessed comes from cumulative frequencies. So remember, for that same example, so we represented the classes instead as less than statements. So any birth weights that were less than 6 pounds, less than 7 pounds, less than 8 pounds, and less than 9 pounds, which all of them were. So the cumulative frequencies, if you remember, were obtained by taking all the previous frequencies and adding them together. So less than 6, there was just 1. Less than 7, well, we had 1 and 11, so that's 12. And then less than 8, so we already had 12, but also we need to include the, I think that would be, 29? So 29 plus 12, that's 41. And lastly, the last category has 7 data values in it, so then we add the 7 to 41, which is 48. And that's our sample size, so we did this correctly. Okay, so we can set up the axes again, just the same way. And, it may make sense instead of using the, we can still use 5.0 here, 6.0, 7.0, 8.0, but the 5.0 category, remember, that really is, we're thinking about less than 6.0. All right. And our scale, again, what should we consider about the scale? Well, we should first look at, okay, what's the largest value in the cumulative frequency column? And that's 48. It's the sample size. So pick a convenient number that's greater than your sample size. I'll go with 50. 50 is convenient. And then we've got 25 in the middle here. And you can go by 5s or by 10s, or you can, cut this in half again. That's 12.5. Although that doesn't really make sense, right? That's not a value that makes sense. In any case, whatever you decide to work with here, when we set up our bars, it's the same process. So here's 1, roughly. I'm exaggerating a tiny bit so that we can at least see it. Less than 7.0, so that's 12. So just underneath that 12.5 mark. And then less than 8.0. So the next bar is going to have a height of 41. That's just around here. Then we drop that down. Okay, last bar has a height of 48. And that's it. That's your cumulative frequency histogram. Some really important things to note. Each bar needs to be taller than the previous one. And we know that because we keep adding positive numbers, right? So, and this is a pattern that we'll formalize a little bit later. But you know you've done this correctly when you can see increasing bars of increasing height, right? Why we use cumulative frequency is more clear now in this, when we see it visually, which is that cumulative frequency isn't necessarily about, the cumulative frequency itself. What it's actually helpful for is you can see which classes contribute more by the difference. So the difference between one and the other, right, gives you a sense of, oh, here's how much our distribution is changing as we go from left to right through our data set. And you can see that too using the frequency histogram, the original kind. But cumulative frequency is helpful for this particular frame of thinking about the data set. And then another sneak peek, this is also connected to how we think about probability distributions. So a glance ahead, when we talk about probability distributions, which will represent very similarly, cumulative frequency histograms, they have a cousin in that, in how we represent probability distributions, which are super helpful, and also how we think about calculating probabilities. So keep an eye out for that.